Hello, Honors Algebra. We're going to do a new type of story problems, and these are going to be ones involving currents, like traveling in water or traveling in air or something like that. So let's get right down to it. Oh, by the way, remember I mentioned before break that there's a very important equation you should be very familiar with, and that's the distance equals the rate times the time. And now remember that we usually do our rates as speeds like miles over hours or miles per hour. Sometimes you'll get kilometers per hour. Okay, that's very important that you have those units because the story doesn't have to give you those units, you may have to convert. All right, so here we have a boat traveling upstream at a distance of 8 miles an hour. Oh, excuse me, a distance of 8 miles in 2 hours. All right, the return trip downstream, that would be with the current at its back, um, only takes an hour and a half. Dude, no, I lost my boat. Ah, it all came apart. Here we go. Hopefully it's all back together. Do 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 do. I don't know why it keeps doing that. All right, guess it's time to stop playing and get back to the math. We've got to find the speed of the boat and the current of the river. Well, I'm gonna let S, or actually, how about B equal the speed of the boat, right? And then we're going to um, maybe C equal the current, the speed of the current. Okay, so now when I'm going upstream, I want to do B minus C because the current is working against me. All right, now this is a speed, this is a speed. I need to put a speed here, and this is where the D equals RT comes in. I know the distance is 8 miles, and I know that it takes 2 hours to do. So distance equals the rate times the time. The time is unknown. I'll divide by 2. This is miles, this is hours. So my time, excuse me, silly me. Um, Let me erase that really quick. 8 is the distance, and then my rate is unknown. My time is 2 hours. There we go. That looks a little bit better. And this is miles divided by hours. So my rate is going to be 4 miles per hour. So B minus C equals 4. Now, the journey downriver is going to be B plus C because the current is pushing the boat along, so it's going to take less time. All right, 5/8 equals R times 1.5 or 3 over 2. All right, and so I'm going to solve. I'm going to get 8 times 2/3, and that's not going to come out very pretty, but that's okay. I'm not afraid of it. So we're going to get, what are we going to get here? 16/3. So the rate downstream is going to be 16/3, which is the same as 5 1/3. And I'm going to go ahead and leave that as 5 1/3. If I look at the system, it says, hey, use elimination. And so I will. I like to listen to the systems that talk to me while I do my homework. All right, so that's going to equal 9 1/3. I might want to go ahead and convert that to 28/3. All right, so I'm going to divide by 2. I'm going to divide by 2. So B is going to equal 28/3 times 1/2, which is going to be 14/3. So the boat is going to be traveling at a speed, where am I at here? 4 2/3 miles per hour. All right. Now if I look at this equation right here, I can put 4 2/3 minus c equals 4. And it looks like, most of you can solve it and say, oh, it's just going to be 2/3. But if you don't see that, we'll go ahead and subtract 2/3, 4 2/3 from both sides. We're going to get negative c equals negative 2/3. So c equals 2/3 miles per hour. Not a very strong current. Not a very strong current at all. But there's the boat speed, and there is the current of the river. The next one I'll do using fract or decimals, just so you show you it doesn't matter. I want you to be well versed in both. Okay, here we have an airplane flying from Florida, Ohio to Florida, 1,000 miles in 3 hours. Now, the return trip takes only 2 hours. Can we find the speed of both the plane and the wind? Well, again, I'm going to define my variables. So I'm going to let P equal the plane speed. Okay. And W equal the wind's speed. And so we're going to use our D equals RT again. And we're going to, the journey down, it takes 3 hours, a longer time than the journey up. So the first one is P minus W. And here I have to go and take 1,000 miles. And I don't know the rate. The time is 3 hours. So the rate is going to be 1,000 divided by 3. And that should be a rate of 333 1/3, I believe. And so I'm going to write that 333. And I'm going to go a couple numbers past the decimal point. Okay, now my second equation is going to be P plus W because the wind is pushing the plane home. And that's an easy one. I have 1,000 miles, 2 hours. That must be 500 miles per hour. Again, it's beautifully set up to do by elimination. So I'm going to say 2P is going to equal 833.33. And I'll divide by 2, And so P is going to equal, hold on one second, 416.67 miles per hour. In other words, it's 416 2/3 miles in an hour. All right, now I can plug it into one of these two equations. So I'll say 416.67 plus W is going to equal 500. Subtract 416. And I'm going to get W equals. Now look, if I had to take 16 away, I'd have 84 left, right? But I'm also taking 2/3 away. So my whole number is going to drop to 83. And if I take 2/3, I'm going to have 1/3 left, which is approximately 0.33 miles per hour. And there's your wind speed, and there's your plane speed. All right, one more example. And on this one, we have Seth riding his bicycle to a friend's house. Hi, Seth. All right, he's riding along. His friend lives 10 miles away, and the trip takes 50 minutes. The return trip only takes him 40 minutes, okay, due to the tailwind. And so there you go, right there. Okay, so here we go. We're gonna let S equals Seth's speed. And we're going to let W equal the wind's speed, right? And so we know we're going 10 miles into a headwind, so we're going to have Seth reduced by the wind. And of course, we're going to have Seth helped by the wind. Now, again, we have to use D equals RT because we're not given a speed. We're given a distance and a time. But you do have to be careful because we usually do things in miles per hour, not in miles per minute. And so before I use my D equals RT off to the side here, I'm going to say 50 minutes out of 60 minutes would be 5/6 of an hour, right? And then 40 minutes of the 60 minutes would be the same as 2/3 of an hour, okay? So I put my 10 miles in, my rate is what I'm looking for, and then I have 5/6. So when I solve for R, I'm going to have 10 over 1 times 6 over 5, which R is going to equal 12, right? 1 there, 2 there, there you go. So the first one is 12, okay? Now the second one is going to be 10 equal to R 2/3, which is going to be 10 over 1 times 3 over 2, and that's going to be 15 miles per hour. So it makes sense. Seth's slowing down because of the wind, so he's only traveling at a rate of 12 miles per hour. But on the way home, he's speeding up because of the wind, and he's going 15 miles an hour. Wouldn't it make sense that his speed is somewhere in between 12 and 15, right? Okay, well, let's see here. I'm going to get 2s. Those are going to cancel. And I'm going to get 27. And half of 27 is going to be 13.5 miles per hour. And we know that S minus W equals 12. Well, you might be able to reason your way through this one. How much do you have to take away from 13 to get it to 12? Well, I'm thinking that W is going to equal 1.5 miles per hour. And so there are your two answers. All right, that's it for the current problems. Mr. Lawrence signing off. Good night, everybody.